right, so yeah, we're coming from yesterday's talk or like a conference in Arise, a lot of stuff about LLMs, very interesting space. So I want to kind of show some of our work that we have been doing past. So going back to the evaluation of enterprise, so typically what you do in enterprise is that you have, if you want to do, for example, manual annotation of like relevancy, you want to create some spreadsheet, you pass it to the chemists or like the scientists or the domain experts, and they will just try to do their best job to say whether it's relevant or not. And humans, some people understand the instruction in one way, maybe another person understands the other way. So you might not have they might annotate something as a 2 and maybe another person says a 1. So it's kind of very noisy. So as I said, we were thinking like, what if we use LLMs to solve some of these issues? One of the first issues is about collecting data, right? So if you want to create some sort of understanding how good a model is or like a RAG system is, we need to have a large amount of queries, because if you have like files, the statistical relevance of whatever you find there is not necessarily great. So the first question would be whether we can use kind of in-parse queries to then create. So if you want to use the in-parse methodology to create more queries based on a few examples, with what kind of I had already mentioned. So that's kind of to generate maybe based on, I don't know, maybe 50 questions, you can expand to 500 or something like this, that kind of have a similar spirit, but maybe because you're feeding different chunks, you have, maybe in this case, you have other compounds here, but the shape of the query is similar, or like covers all of the different types of questions. Yeah, so that's kind of the benchmark, right? So once we have the benchmark, we want to try to understand if our models are good enough or not. So for that, we were thinking, well, let's try just to do LLM as a judge, which kind of most people are doing nowadays. And we do that. The problem that we see is that the LLMs are typically kind of more lenient, right? So they tend to agree with the user and say, yeah, this may be relevant, but the human expert may say it's not so relevant. But kind of what we discover is that there's some agreement or like a high agreement between the LLM judge and the human if you look across versions of the RAG system, right? So each of these bars, vertical lines, is one different kind of retrieval strategy. So you see that more or less, whenever the LLM as the judge says, oh, this system is better than this, the human will also say the same. So this is we created this open source package called Ragelo, and then we were just exploring, this kind of empirical result, whether we can automate the task of the human and still get a feeling of which model to use later to either put in production or ask a human to now evaluate, right? So maybe in this case, instead of saying, okay, these are 10 different variations, please validate all of them, you could say, okay, maybe we started from these, and then later we discover, okay, this is good enough. Let's let the domain experts have a look. So it's a bit less work for them. Yeah, so kind of summarizing these findings and bring the findings. So LLMs tend to overestimate, but what we see is that when you test across many queries, like let's say more than 200 queries, in average, it seems like the LLMs agree with humans in the kind of relative scoring, right? So if LLM says model A is better than B, then the human will say the same. I mean, human in this case, I mean like expert domain experts. And any human. So many kind of open questions there is, right, so it could be that, for example, if you are using the RAG system, you are using GPT-4o to generate the answers, and then you also use 4o to evaluate, could there be some bias there in how the judge questions or the answers?
So doesn't the judge have to be better than the guy that will generate the answer?
It depends, right? So you can have like many variations. Maybe you have a system that uses GPT-3.5 for some parts, and then 4.0 for generation, but there are many things that you can vary. The point is that the judge has to be the best model that you could have access to, so typically 4.0. But the question is more like, okay, if you actually have a system that is 4.0 generation and then 4.0 judge, are we getting into some trouble because now it's not longer reliable?
Yeah, I've heard this to be one of the biggest like pushbacks against LLMs as judges. I recently had a conversation with an applied researcher at eBay who helped build their evaluation system, and he said that they realized like separation is actually very important between who's generating and who's evaluating, because more LLMs do tend to favor their own output because they've just seen that training data. So they feel like, oh, I answered this way, it must be right.
Yeah.
Yeah, there's an interesting paper from Cohere where they kind of show the same, that GPT-4 doesn't like Cohere output, and even from the strongest Cohere model. But then they show that if you use actually an ensemble of different weaker judges and average across of them, that this bias kind of disappears. So that's kind of an interesting.
So isn't that where the critique started to comment with the GPT critique, with the model which does a critique? I don't know what's the difference between the judge and.
What is the difference between the judge and the critique? The critique is more explanatory, I think. It explains what's wrong with the answer, and the judge just says thumbs up or thumbs down or medium.
Model A and Model B that you're referring to, this is just a retrieval system, right?
Like anything that you can change in the RAG pipeline.
But what you're asking the thing to judge is, given that I gave you these documents, tell me how relevant they are.
Yeah, I'm sure going to explain more, but yes, in this case, it's just saying, this is my query, this is my passage, are these good or not?
Got it.
So we kind of run this for some actual customer data. So this is like about 4 use cases. And we just made and so on. And we had, again, humans and LLM as a judge, and across all of these cases we see that there's some sort of strong correlation for matching the LLM as a judge with humans. Of course, when you see the relative comparison, right? Like you always see like the LLM is always overestimated. The relative one.
So it's not true. There's one where it's underestimated. LX and DCD.
This one.
Yeah,
true. Right, so that was about like evaluating the relevance of query passages. So then we said, okay, what if you have the LLM also evaluate the answers? The problem there is that, okay, maybe you have a bunch of questions and a bunch of answers, and in one question, model A is better, but the second question, model B is better. So how do you at the end decide what to use in practice, right? So for that, we're looking into this Elo-ranking. So it's like a chess term. So the way it works roughly is that you kind of compete against each other. Each player has a score, and if you win, you get some points, and if you lose points. And the interesting part is that if you win against a stronger player, you get even more points than you would if you has like the same score. And if you lose, it's the same, but the opposite direction. So what we want to do, let me just explain the entire pipeline. So this is kind of the data generation part, right? You have queries, the RAG system to be including the processing or anything that you can change on the RAG system. We collect the answer as well as the context, right? So for the answer you have templates some hits. And then we ask Ragelo to do these steps. So first, we will say, okay, for this document and query, tell me if it's relevant. This was the first part we mentioned. And then we say, okay, now you have 2 answers. One is answer from agent A, answer for agent B. And we did both at the same time, as well as the annotations from the last step, right? So you would say, maybe answer A is citing some document, and then in the context, you would say, okay, this document is maybe not relevant. So the LLM has kind of visibility for all of this. And then we ask it, okay, please tell me which one is better, based on some parameters that we can add in the prompt. And then it will say, okay, maybe in this case B is better. So we do this for all of the queries and all of the answers and all of the agents. And then we play this kind of tournament style where we are going to say, okay, randomize the pairs of A and B, get the result, and then if you win, get some points. If you lose some points, the same Elo algorithm. And in the end, you get like a ranked list of agents, right? So I don't know, in this case, like you say like, the score is 2830, and then the other one is 2845. And then, the higher the score, the better it is, like in general. So this is what we were kind of thinking.
What are you passing from the query context evaluation stage to the evidence-based pairwise stage?
So the annotations. So here you have, let's say for query A, document A,
You'll get some score.
either like 0, 1, 2,
Okay.
or relevant and not relevant. And then for all of the context that the answer used, we will pass those. I will show the query kind of. But basically have like the picture of the world saying there exists these documents, some are relevant, some are not, and then it sees both answers, which are citing these documents. So kind of in practice, that's how it looks. So you have just a CSV with queries. These are the documents with some document ID and the extraction, the passage extraction. And then the answers where you have the name of the agent and then the answer that may have citations that point at these document IDs. That's kind of the format we pass. So coming back to the first part, right? So how do we do the retrieve document annotation? So we have like a very basic prompt. I mean, you can of course customize this as you want. And this I'm just putting here the code just to see how it looks in general, but you are just very basically going to prompt the LLM to say, okay, I'm going to give you this question. This is the document. Please tell me if it's relevant or not. And here you could inject like some things to look for and like pay attention to when deciding if it's relevant or not. And then you get something like that. So you have the document that says, okay, it's very relevant and why. I think this is very important actually. So lots of these LLMs platforms are doing something like this, but they kind of stick to the number. But I mean, there are many out there. But for me, if you're actually trying to solve some problem, you actually want to look at the explanation because this help you decide if your prompt is good or not, right? Because if maybe say it's very relevant and the reason is something that it should not be, then you can tweak the prompt and say, okay, please make sure that you don't make it relevant when this happens.
Do you do anything with the explanation after? Do you take that data up?
Is that used for the Elo rating or is that just?
This is used later for the in the next step, the pairwise comparison. But as I said, the first stage, you just want to also look at just answer yourself, just have a feeling how it's working.
So is that another with the actual explanation, that information? What do you do? Do you do anything with that? So once you've got the explanation,
yeah. So you can, I mean, as a developer of the prompt, you can look at some cases and just understand. But then later we will template this into the next step.
Okay.
Pairwise.
I'm confused. Wouldn't it be better to do comparison at the beginning, not at the, because this is comparing one document, right?
This is like just ranking, annotating one query and one document.
One query, one document.
Yes.
I mean, I think it would mostly say most things are relevant or somewhat relevant.
Well, that's kind of what we saw in the bar charts, that most of the times overestimates.
Okay.
But when you compare relatively,
Comparison is better, right?
yeah.
So, I mean, okay, yeah.
So he would say maybe more often he would say very relevant, or maybe
Yeah,
relevant.
Yeah.
And the human expert would say no, this is not.
Okay.
So that's the data set out of the first stage, basically.
I can.
Yeah, this is going to be a bit more hard to read, but this is the pairwise comparison prompt. So here we're just saying, okay, I'm going to give you two answers, where I'm going to give you the documents and whether they're relevant or not. So you can see, for example, here we have the reference documents, this is the ID, and this the explanation we got from the previous step. So it's very relevant, because blah, blah, blah. It's another document. And here we have the answer of agent A and the answer of agent B. And typically the answer, depending on your ARC system, may cite these IDs. So that's how you can figure out whether Because you're trying to evaluate the system as a whole, right? So it could be that the answer looks okay, ignoring that there are documents that are more relevant that we're not using the answer. So it's also very important to have like a full view of all of the documents that are relevant. Of course, there's some limitation, right? You already have access to the documents retrieved by these answers. Right, so then you're going to say, okay, please explain why each answer is better, and so on. So this is the kind of results. So you have like a agent A name, agent B name, and then the answer, and then it's going to say, you know, assistant A response, not very brief, and only mentions blah, blah, blah. Assistant B's response is more comprehensive, blah, 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 and then final verdict, B. So you have the last column is B, which means that in this kind of game, like we play A versus B, and B one. And we just do it for every query and every pair of agents. And we collect the answers. So those are kind of the results of the games. There's also an option of a type, like say C is a type. Most of the times it doesn't have types because I guess that's like I find it to just say, okay, A or B, right? Very but yeah, so the point is that you connect this, and then at the end you kind of run the Elo algorithm, and then you get something like this. So it would be saying, well, maybe you just have a look at these two instead of these two, so these are better. And just to kind of show you how it works or how it looks in practice, this is something we did for a client, and then we had like, you know, like a QA chain, a QA chain P2, and then this is GPT, GPT-4, Da Vinci, right? So you have a bunch of many.
It's from the good old times of Da Vinci.
Yeah.
Very long time ago. You guys don't remember.
And then, you know, from this list, instead of going to the experts for all of these, we can say, okay, maybe let's focus on this. And then they can decide which one is actually better. Yeah, so this kind of about how Ragelo works. I'm actually want to demo like how it looks in practice later, but are there any questions at this point?
I know the focus here is quality of output, but when you're then speaking to a client, how much does the speed and the cost come into play when deciding what they do next?
Yeah, that's a good point. So I guess, I mean, this is just one metric that we can extract about the models. But for you to say, okay, you know, completing the answer for this one, it takes this latency and this cost, and this also can place into the decision.
Yeah.
That's a good point.
The question is that, sorry, you had that number like 1256, I can't read it properly, maybe it's 1256, right? Now, he says that, hey, go ahead and start fine tuning it. Can you decide like what's an upper bound on that, like 1300 or 1350 we can go, this is how good we can get towards getting you better answers? Is there a upper bound that you can decide, or how do you decide?
No, that's
Is
like
there room for
that's like a
improvement?
game score.
Correct, right.
Yeah. That's based on the number of players there are.
Yes, yes.
Right, but
Yeah.
what I'm saying is that you know that you're getting better and better.
Keep going.
Yeah, how much room is left there and how much you can extract out of it through fine tuning or other means is what I'm saying.
Yeah, that's a good point. So I think you shouldn't really read too much into the actual numbers. This is just saying like the ranking.
Yes.
But I guess if you want to know if you can keep pushing, I mean, I don't know, you might have a feeling by just asking the actual users. Like for example, you say these are good enough, they just ask users. And if they come with like, oh, this is garbage, then maybe that means that you go back and, you know, start from scratch or do another approach. But I'm not saying to just completely remove the user, right? It's just like helping you be a bit more efficient when doing these evaluations.
Do you think that there's, sorry, you can ask a question first.
Go ahead.
I was just going to say, are there certain types of queries that this approach is best for and not so? And I'll give an example, like maybe typically in recruiting, part of the output would be, do you want to reach out to this candidate? Maybe part of the output would be, do you want to set up an interview, which is maybe the next stage, and so on and so forth. And I just imagine that there are certain types of queries that this is potentially more relevant for others? Have you seen that, or is it, do you think this is something you can use across the board? Because there's more of a human in the loop in the scenario that I'm talking about that will have a subjective view on the output, depending on the human, right? Even though they're experts.
Yeah. I think like normally you kind of always start with the baseline from humans, I would say. Like maybe you have an existing system and then you already know what works and what doesn't. And then you can use this information to then maybe put into the prompts to say like, okay, this answer should match with this type of query.
So the domain expertise again is still right, there's no way of getting around that.
No. I mean, all of these prompts have to be like designed for that domain and for that particular company. I mean, it's like also feedback loop, right? Like once you try something, maybe you let the experts try the system, they have some feedback, and then you can integrate this feedback back into the evaluation prompts so that now you.
But and not to put on the book, but we're working in this scenario, which makes it towards the client's view of what good looks like. But if the client is an expert, whatever that may mean, but in recruitment, sometimes some experts can miss things. And so how do we ensure that we can give them the full opportunity to explore what's possible versus kind of stopping at their expert knowledge is something I'm thinking, and I think about this as like transferable skills. In jobs, some people hire on experience, but you could hire on potential if you understood what those things were. So there's something that's playing in my mind. And you're more.
Yeah, so I think if you calibrate your evaluation on the experts, you're always gonna inherit their biases to some extent.
Yeah.
Right. And the good thing about this approach is that looking at the intermediate explanations, you can actually catch that.
Okay.
Right. You get this is a good candidate because they have very big elfish ears. Well, that's not something I want to pay attention to, so I'm gonna put in the prompt not to pay attention to the shape of the ears.
Right. So it's iterative as well. That part of it. Yeah. Okay.
Have you actually related to these discussions, because you can always get feedback, experts may not be accurate, this may not be accurate. So, or to some extent, or how far you want to go. Have you looked into some form of active learning on top of this system or not?
Yeah, so I mean, there are some companies that do that. But you mean like for example, as the system evolves, like maybe you have more of
as like, I think it's related to his question and the point that he brought up, right? Because it's kind of, I don't know, impossible is the wrong word these days. Everything can be possible at some point, but like, you never know how you benchmark, like, okay, your benchmark has a limitation too, right? So, and not your system, any system in general. So you can keep going. How far can you go? The only way to know is then some kind of a feedback, right? And then if you combine that to kind of like refine tune or retrain your system and automate that, and how can you decide how that part works? Like in older system, active learning was much easier, like yes, no, and it's like you get better. But I wonder if you have implemented something like that here. It's very complex. So
yeah, I think I'll kind of rephrase what you're saying is, suppose you have a customer engagement, right? Before you start the engagement with him, you show him some of the slide and say, hey, with a QA chain, you can get to 1200. And then if you want to get to the reasoning and that part implemented, you get a 50-point.
I think even in production, that's the whole point. So it's like having tried.
Are you happy over here or?
Yeah.
This effort.
I think it's important that you have some compass, right? That's guiding you in the right direction. And this is not much more than such a compass. How you actually do the iteration, whether you want to like sprinkle salt on it or do more fine tuning or that is your own sort of process, but you want to know if you're improving.
Yeah, or let's say your customer, how can they agree
Yeah.
that you're at a good point, you're done?
Yeah,
How do
you're
you-
never done. You're done when the deadline has been.
Yeah, or done in
When
a
the money runs
phase,
out.
it done in a phase, right? There, I mean, yeah, other than a deadline and we do things like, how, what is your frame of mind on that and how do you evaluate that? That, hey,
Yeah.
we accomplished phase 2 now.
Well, probably next week a model is gonna come out that
Yeah.
seems to be a lot better. So then you wanna plug it in and play a few of these
Yeah.
games. And that's also, by the way, a charm of the Elo system. You don't have to replay the whole tournament with everything. You can like plug in later a stronger player. And if it's beating all the weaker players, it immediately gets a high Elo score.
Oh, I see, yeah.
So we haven't really done it in a online monitoring environment with this, but it could work very well for them.
Yeah, and also on the monitoring part, it's important. But I don't know, like, have you seen, for example, how people give feedback normally? I don't know. I feel like sometimes they see, this is bad, maybe it's not bad. It's just like they feel it's bad, and it's very noisy, right? So I don't know if like it's important to collect the data and then use it for the next loop. But I don't know, like at this point, I just plug it into some automated system and let it crunch.
So let me ask you another question. I wonder, have you also worked into the HCI of the things, like how do you relevant to the question, how you interface with this, how do you say I like it or not, or why, have you dug into that part or not?
Not much.
Okay.
So we have that kind of feedback mechanism in our platform. But we see that the number of clicks that you can actually get in an enterprise setting is just very small. And then you have like,
But a lot of it then depends on how you collect that, even what's the color, how
now
do
imagine
you-
this large German chemical company. There's one really grumpy engineer. And he will like do thumbs down on all of his questions.
Yeah.
Try to use that for active learning.
How's it going, guys?
Hey, welcome.
Oh, sorry, I'm interrupting.
Yeah, no.
Have you guys looked into like using GPT-3 or like using a lower model to evaluate these higher models? And has it been do you always use the smartest, best model to judge?
Yes.
And have you looked at evaluating the lesser models?
Not in that direction, but I guess before all, we were using
Okay, yeah, I didn't use for.
There's this Cohere paper is really interesting.
Okay.
They did that evaluation and they see that like models below a certain capability class are basically pretty lousy judges.
Okay. Interesting. Because that's one of the.
Because they don't correlate with human judgment.
Okay, interesting. Because that's one of the things that you kind of need to be scalable, even with the expert question, right? It's like, if you were trying to use LLM evaluation and your LLM are harder than the average feedback you get, like how do you balance that? That's the same question as lesser versus good LLMs.
Yeah, and also something interesting on the other side. So when you're going from 4 to 4.0 on the generation side,
Interesting.
is that comparing RAG created with 4 and RAG created with 4.0, and you put it to this Elo score, it will always say that 4 is better. But if you then look into the explanation, I mean, if you just run the numbers, you get numbers, and that's it, end of the story, right? But if you actually look into the reasonings why the 4.0 won the games, it's typically because of something that was not in the prompt. Maybe the way the answer is structured is more beautiful.
Yeah.
And it's that's better. So I think it's also important to not only rely on these numbers at the end, but also dig into the reasons to try to understand why.
So one of the things you could also look at is there was a few days back, there was an article by, I think the Hugging Face co-founder and some other few guys, where they attempted the math Olympiad problems. And what they showed was, they showed the chain of reasoning to go through, and they were able to blind solve some of the other unknown problems as well. So they kind of surpassed the prior, I think almost 7 or 8 new problems they saw, which are not even seen. So the way that they did was because it's not subjective, right? In the math thing, you have different ways to verify it, right? So it built its reasoning over time. And so I think you should probably take a look at that paper sometime. So it's fairly complicated what they've written, but they were able to solve new class of problems, which was kind of previously thought was not possible.
Yeah. Well, by chain reason.
Yes.
Right, so maybe moving a bit beyond the evaluation, what was maybe mention a bit more about these RAG systems, like the strategies for creating RAGs. So one of these questions that we get from a customer is like, I want to know what, let's say you have a team in the company, you want to know what every single project that they have done. Or I want to do like a literature review on certain topic that they have accumulated for like 50 years. Or legal research, as an example. So typically, you know, if you do normal RAG, it's not going to be so good, right? Because you are only looking maybe at 5, 10 chunks, and then out of these 10, maybe only 2 or 3 are relevant. So you know, the chances that you catch an article that describes the answer in this entirety is very low, right? So you might want to collect different chunks from many different documents and then kind of synthesize an answer from there. So what to just describe some of these techniques. Maybe this is it was new like a few months ago. Now it's not new anymore. Something called the RAG fusion. Are you familiar with RAG fusion? Yeah. So the idea is that you take a query, you ask the LLM to then create synthetic queries related to the original one. So for example, this is like what are considered using AI, and then the LLM says, okay, similar queries could be like NVIDIA GPUs, AI hardware manufacturers with GPU, just make these things up. For each of them, we retrieve the context, the documents. Then we do the reciprocal RAG fusion, which is this algorithm that kind of merges the lists. And then we feed the top K results back into the LLM to generate the answer. So that's okay, right? But the problem is that what if, I mean, okay, what are you getting by doing this? You're kind of going to be like a breadth search, right? You're going, whatever documents you get here, maybe from here you get another document that you wouldn't see if you only look at this one query. So in some sense, you're kind of having seeing more stuff, or like seeing stuff that you don't have access to normally, right? But it will not be no, right? Because you're still doing like, okay, this is kind of related, and then you are still only feeding maybe the top 5. So what we were thinking is something like iterative process using this Ragelo evaluator. So we start with a similar situation. We have a query, we ask it to generate similar queries. Then we get the context, and then we ask Ragelo to rank the relevance of the retrieved documents. So it could be, in this case, maybe the 3, you got 3 and 2 of them are relevant, here's only 1. And then you pass those to the LLM to generate like an intermediate answer. So you can say, okay, please, given this information, tell me what is the current state of your understanding of this subject. So okay, this is a similar situation, right? You have the query, you generate the queries. We get the first answer, which is saying something like, based on the information so far, so that information retrieved from these queries. Okay, these are the type of accelerators. There are some kind of mechanism examples. And then we're going to ask it to refine it, right? So we need to ask the LLM, what are you missing from this to answer this question? And then the LLM will now answer something like, okay, I need more information about specific architectural features or real world examples, or something to expand more on that. And from there, it's going to go back to the origin, to the start. Okay, now please give me queries that could answer some of these things that I'm missing. And then we generate, these answers, and then you kind of go on and on. Going back to the thing. Right, so it's like a general iterative process that is going to allow you to cover kind of in-depth, you go more in depth, right? Because one generation might not be enough, so you kind of do it iteratively. And also by using the evaluation, you're also making sure that you are only looking at very relevant.
The question, how does Ragelo know which are the right documents in that? Like from NVIDIA GPU, you got 3 documents, the 2 of them are correct.
Yeah, it's just by the prompt that we saw before, he's just going to say, okay, this is my query, and these are documents, please tell me if they're relevant or not. So it's like a filtering step, but based on the LLM.
So the situation here is that for these type of questions where you need to know all the answers, they're very valuable answers. So you can actually take quite a long time before you retrieve all the answers. You can do many LLM judgments. You can fire 1,000 queries and iterate through all of them and burn like a fair amount of OpenAI credits to actually do that, because the answer in the end is going to be quite valuable and save the searcher like hours of time.
I see.
Yeah, and so that simple judgment is part of that, and it just iterates through many of them.
Do you see many businesses and customers using this very long, expensive approach here already?
Well, we see the demand, so that they want to really know about this and have like a huge summary of everything there is to know about this thing.
Yeah.
So if you go to somebody who does patent searches, this is what they do all day.
Yeah.
Right? And they take many hours and days to write the report.
Yeah, and it's probably not something you would put like on a chat system, right? It's something that you can fire.
But you have to give them back the reference to the original document, right? Wouldn't they expect to see?
Yeah.
Absolutely.
So at the end you have like a report.
Report, and then you have references
All of the
to all
references.
of them.
And in my sites, 100, 200.
And you're guaranteed at that point that you have done a complete coverage of all the documents and there are no extra references left anyway.
Well, in the end, it's always based on the LLM, right? So you will decide at some point, you can have like some heuristics to say, okay, I'm keep exploring and I don't have any new relevant hits. Maybe that's enough to stop. But you will never read.
So it's quite similar to how Perplexity.
Yes, yeah.
Yeah, I think that's they do something right. Like you can have like an image, and then you can say, okay, for each line in the image, you are going to do one search, and then collect stuff. That's what you enjoy.
Well, one of the benefits of one of the Perplexity does is, unlike ChatGPT, I think they've like put something in to force it to have references for like all of this insights, which is kind of what I see here. You're like getting the LLM to go using RAG, go get sources and use that to build up a response. That's exactly what Perplexity does. That's where
I think Perplexity only has like a top K results. But I mean, I think they do like many queries, but it's just like whatever the user wants. Let's say you want to say, what is the price of each of these AWS machines? We just do, okay, price of this one, price of
No, it actually goes and changes the query.
In the next
modifies, it modifies the query and says, this is what I'm going to actually, so you can briefly see the snippet of the query being redone.
Yeah.
And then it fires off the search.
Yeah.
So and then it says, from there, I'm going to now get these results. And this is my criteria to go and filter it out or whatever you want to call it. But I found that the way that it changes the query is pretty interesting. When you give them a small query, it makes it a lot more elaborate.
Right, so there are a lot of kind of open source tools to do these RAG systems. And everybody claims that you can do this in 3 lines of code. Maybe it's like for
Not everybody.
But it's like for them friends, they want you to go through the quick start page and then continue, right? So it's the optimization. So it makes sense. But as we showed before, to actually do it in production in enterprise, it takes much more, like more modules and scalability and all that. Something we notice with working with enterprise is that the kind of the scalability of the large language models have made it so that everybody can just start from, like you don't have to be an AI expert.
This hybrid search, what do you mean by hard filters?
Just like saying, please don't give me any results that don't have this metadata, right? Yeah, so then, because everybody can do it, people in enterprise also want to do it. So some of the questions we were thinking is like, how can we empower these users, which not have to do all of these, but still, be able to have their own strategies for creating the RAG systems. So we were creating this runtime. It's like a framework agnostic runtime. So we can basically just write your RAG system in any like Llama interface or just directly for an OpenAI or LangChain, whatever. And we can provide a bunch of stuff like an API that you can just expose the right endpoints to plug into the system and the production system. You have like a local debugging UI and so on. So like some sort of package that we can give our clients, then they can develop the agents that then we can just run into our infrastructure, right? Because we're not going to just take a random script from someone and put it in production. So this is like a way to kind of get a structured way for more people to develop, and it also helps us internally to just experiment very quickly and not have to do a very long PR review process, but because you are changing some core infrastructure, right? So some very simple approach of the architecture. So I want to just quickly show you how it works. So this is the UI, and then you have your model that you have created here. So for example, I have like a naive RAG agent, and then I can say, what's there, for example. It will just, collect some results from a search engine. Our search engine template into the prompt, and then give the results. So as we were saying, these are the references. So when you click there, it goes to the actual document. This one. Okay, so then you can, for example, you say, well, this looks good enough. Maybe I want to now check the RAG Fusion one. How's that look? The same, and then RAG Fusion will do something else, right? It will first regenerate these queries that are related to the original one. It will do for each of them, it will retrieve the 10 documents, and then it will do the fusion algorithm. And at the end, also template the top 5. And then you get some other answers. So maybe you say, okay, this also looks good. So then you go into the collect mode. In the collect mode, you have the selected agents, and here you can just pass some list of benchmarks. So let's say these ones, you have collected these maybe from the experts, or you have done, the in-parse methodology to create more synthetic queries. And then you will just say, okay, please collect all the answers. And it will go one by one and collect all the answers for each, and then store them. Not going to wait for all of that to happen, so I just have some saved collection.
You guys don't use any framework underneath, right? This is all your own custom code, right?
So the implementation of the agent could be in any framework, but this is like the wrapper around.
The wrapper is your thing. Like you don't use like Llama Index or LangChain. It's all the connector. The glue logic is all yours.
Yeah. Right. So let's say you have already. If I click here, we just do the things that are missing. But for example, one of them are ready. So then I can move to the evaluation phase. The evaluation phase reuses the Ragelo thing. So the right one. So then these are kind of the regular configuration, right? So say the judge model is for all. I'm going to do 20 parallel processes at the same time. My pairwise evaluation, I'm going to look at the correctness and the completeness, and you just kind of the prompt that you saw in the pairwise. And then when you click pairwise, it will just collect rank or evaluate all of the responses, and then do the pairwise competition between the agents. And at the end, it gives you the score. In this case, I just have 2 agents, right? So you just, they say the RAG fusion is better. Don't take any, advice from this because I'm only using like 5 queries. And the interesting part is that you can actually see like the 2 answers, right? For example, in this case, maybe this one, you have the 2 answers from the models, and then you have the explanation. Okay, in this case, it's a tie. So it's saying a C is a tie, and it says why. So it's an A answer, blah, blah, blah. And then the comparison is that both are effectively, and then maybe they are the same answer actually. That's why it's saying it's a tie. So, and then, okay, so once that's developed, so as a developer, you go through this process, you decide, okay, maybe it's a good point to actually deploy production. So as easily as you created that code, you just push that. And because you have this kind of serving runtime, you can just connect directly into the infrastructure and then start serving from the front end your new agent. Yeah, so just wrapping up. So as we kind of saw during the previous presentation on this one, the RAG what enables us is that we can connect confidential sources to LLMs, right? Because we cannot really train the LLMs with confidential data because then we don't know, if the capacity is right or not. So I think the best way to handle this type of problems is to actually optimize the retrieval part, right? So for that, there are many techniques. You can do neural, you can do hybrid, put your rankers, fine tune, right? So there's a lot of variety that you can play with. And what is hard is that because it's so easy to have so many different systems, is that you need really some evaluation framework. And there's a lot of LMOps out there. Actually, today, Athena AI announced that they are supporting now the pairwise evaluator, so that's good that they are moving to this direction. So we're also investigating on that, and we have our own Ragelo open source package. And when you actually work in enterprise, everybody is doing this, right? So it's not now only AI engineers that can do it. So it's also important for us to collaborate with the clients and then allow them to generate their own logic. Because at the end of the day, they are kind of domain experts in some way. So kind of giving them tools for them to integrate these agents into our platform in a way that is kind of flexible and we can prototype very easily. Yeah, so that's the end.